Hey, this video lecture is to give you a really quick overview of ATP, which stands for adenosine triphosphate. This is our main cellular fuel, so the gas that kind of provides the energy needed for the cell to function. So it's a really, really important chemical, one I know that you've all heard of, but maybe don't necessarily know all of the details about. It's a little bit more complex than what I'm going to present to you today, but I just want you to have a real general overview of how this works. First of all, ATP is a chemical fuel. It's made up of three general parts: an adenosine, which is a nitrogen type compound, a sugar called ribose, and then there are three phosphate groups that are attached to the end. Now the energy from ATP comes in these bonds between the phosphate groups. So in the bond between the third and the second, there's a ton of energy. In the bond between the second and the first, there's some energy, and the bond between the sugar and the phosphate, there's a little bit of energy. So really what we're going to be focusing on is what happens with these bonds between the phosphate groups. That is what drives this reaction. I like to use the analogy of your cell phones and the phosphates as being the bars on how charged your battery is. So for ATP, this is like your fully charged cell phone. You have all of your bonds, okay? And what's going to happen is that as you turn your phone on and as you use it, you're going to start to lose bars. Well, that's what happens with the cell. As the cell starts to use energy in this ATP form, it's going to start to lose phosphate groups. Okay, we're going to drop them off, and as we drop them off, we're going to actually release energy. So when an ATP gets rid of a phosphate group, so we're going to be looking at going this way, it forms a chemical called ADP, D for diphosphate, meaning that now there's only two. And this little pocket of energy, or your cell phone bar, is released to provide the cell with the energy that it needs. Now, the reverse also takes place. At the end of the day, when you have used your cell phone all day, you go home, you plug it in, and you charge up those bars again. And the cell also does that. It charges up that ATP so that it's holding three phosphates again, so that it's fully charged. So when we add phosphates to ADP to make ATP, we're actually storing energy. And so this is basically what we're all going to be focusing on when we talk about cellular energy. ATP getting rid of phosphates for energy to be used by the cell, and ADP gathering phosphates in order to store energy for when the cell needs it. And again, think about your phone. You use your phone, you get rid of bars, just like the phosphates. You plug your phone in, you accumulate bars, you accumulate phosphates, just like the ADP does. It's energy that you can use later when it's done. Now, two terms that you might hear is the idea of hydrolysis. That's going to be when phosphate is lost. That's what we call that process. And phosphorylation is when phosphate is added to another substance. So again, this is going to be using energy. This will involve storing energy. Two other compounds that you're going to hear about when we talk about cellular respiration is NADH and FADH2. These work very similarly to ATP. They're a little bit different. They're obviously different chemically, and again, I'm giving you a super simplified version of this. But it works kind of the same way, except that instead of phosphate groups, we're getting rid of and accumulating hydrogens. So NADH can release its hydrogen through an oxidation reaction, and that releases energy. Then it becomes NAD+. NAD+ can pick up hydrogens to become NADH to store energy. And FADH2 works the same way. So when you see these chemicals in the next couple videos regarding cellular respiration, you know that ATP, NADH, and FADH2 are all energy-releasing chemicals that can be stored up or, kind of charged back up in order to release energy at another time. They're all different chemicals, but the general premise of how they work is the same.